All right, and we are live. So, good morning, good afternoon, and good evening to our viewers from around the world. Thank you so much for joining us on this new webinar by AppSecEngineer. I'm your host Anish Bhargav, and I'm joined by Debarshi Das, the resident security engineer and instructor at AppSecEngineer. So, thanks for joining us, Debarshi.
Thanks for having me.
So today we'll be getting into uh, a quick live code session where Debash will be talking to you about secure code review. This webinar will actually be a small taste of what you can expect from our full 4-day bootcamp hosted live by our instructors at AppSec Engineer. And Debashi is one of those instructors. So we have 6 different bootcamps covering topics like threat modeling, DevSecOps, AI security, secure code review, and cloud native security, as well as supply chain security. So I'll give you the full details on all this exciting stuff coming up in our live boot camps at the end of this webinar. Plus, there's going to be a little, special gift for you, all of you who stick around to the end. So stay tuned and trust me, you don't want to miss this. Now let's get back to the webinar. So Debashi, take it away.
Right, thank you so much for the introduction. So let's begin. So today's webinar is about code review, as Anish initiated you all. So we'll be going into how you should do code reviews, why you should do code reviews, how they are done, and how to get the most out of a code review. Right? We're going to look at approaches, and we're going to end it with a demo of applying all the approaches we learned. So let's begin. So what is a code review? A code review is essentially when when you have full access to the documentation and the code base of an application, and you have a free hand basically to poke around the application, to traverse the application source code and try and find some anti-patterns or insecure uses of some vulnerable functions that are specific to the application, to the language, to the tech stack. So essentially, the idea is you go around the code base, you scan the code base manually, and you try and figure out what could go wrong in the code base when user input is flowing into the code base and it's being processed. That is what a typical code review looks like. But why do you even do code reviews? Well, first of all, it's faster than pen testing. It's pretty straightforward. All you need is the code and the documentation, and you can get started. And you can get started with a review. And moreover, you can get more coverage with a code review than with pen testing because you get to see everything, right? It's white box, so you get to see everything. So there's a very little guesswork involved. In pen testing, it's pretty much black box, right? Even if it's a gray box or white box, still there's a lot of guesswork involved. But with code reviews, you are given everything, right? So you know what there is, what there isn't. So you don't have to go around, do a lot of guesswork, a lot of recon. So it's much faster to get started and get it over with. Compliance, always same for pen testing and code reviews. These are just parts of compliance. So definitely finding complex bugs. So you can find complex bugs with pen testing as well. But here's the thing. Like I said, there's a lot of guesswork involved, right? You're poking around the system, you're trying to create a mental model and trying to map out all the features of the application, all the states the application is in. But with code review, you already know it. You're already given a free hand. You're given the cheat sheet, whatever. It's an open book exam, right? So you can basically map out everything from the start, from the get go, without having to do a lot of guesswork. So it's very easy to find and chain multiple exploit primitives, what we say, basically vulnerabilities with not much impact in themselves, but they can form, like, together, when chained together, they can form a lot of impact, right? Which is called a full chain exploit. So it's very easy when you have the code to form a full chain exploit than it is when you're doing pen testing or any sort of black box testing. Fine-tuned DevSecOps tooling. So development and security is shifting left as we speak. There are tons of tooling that are being added to the DevOps pipeline to make sure that vulnerabilities are caught before they even make it to production, or even in some cases to dev builds. So some of the tooling in DevSecOps are SAST and DAST. Like, these are the most common toolings, right? Which you add to your pipeline to catch vulnerabilities. What happens is these are not magic bullets, right? So it's not you can plug it in and just forget about it and it'll fix all your vulnerabilities. No, that's not how it works. That is not how it works. If you do that, you will end up with a tsunami of false positives, right? That is just not how it works. So how do you get around that, right? How do you make sure that your DevOps tooling is working as intended? You do that by doing an initial code review extracting patterns, right? Extracting insecure patterns or code patterns, paradigms from your code review, and then using that information to develop custom rule sets so that these tools that are running, they will get maximum coverage and not emit false positives, which are exclusive to your code base, right? So you don't want these tools to be running like a generic scanner. You want them to be fine-tuned to your code base. And initial step towards that is code review. Spotting backdoors. Now this is exclusively human. There is no SaaS tool right now or DAS tool, whatever, which guarantees spots backdoors. If you look at some famous backdoors from like last 2 years, we can look at the XZ backdoor, right? What happened there was I cannot recall their name, but a Microsoft employee, they were basically performance testing OpenSSH, and they happened to notice that it was taking more time than usual to perform some connections or operations, right? And once they got the hint of something's wrong, they looked into the code base, and that's how they figured out that, hey, this is not right, this is a backdoor. So definitely spotting backdoors, there is no other way. There is no alternative to human eye over code. Now, you know what code review is, you know why you should do it, but how do you even begin, right? Like, you have the code base, but what do you even do? Well, there are approaches, but before we get into approaches, there are some critical concepts that you need to understand for doing code review. Attacker controlled input data, or ACID, also known as state. So attacker control input data, or ACID, is basically any untrusted user input that is flowing into your application. That's all it is. And in your entire career of code reviews, you will mostly be chasing ACID, right? You will mostly be chasing where attacker control input data, or untrusted user input data is coming, how, which components it's touching, and where is it flowing into. And remember, acid always burns. So whatever untrusted data touches, it burns, it taints. So you have to keep this in mind. That's the point of following the untrusted data, right? So to make sure that as you're following it, there is no insecure patterns or vulnerabilities introduced in any of the components or any of the functions. So to follow acid, you basically start from the source. The source is essentially the entry points to your application, right? If it's, let's say, a full stack web app, it would be the endpoints. For example, you can see in the screenshot there is an endpoint which is a post endpoint, which is upload. So upload is an entry point where untrusted user input can flow into your application. And inside your application, in this particular case, it's flowing as a file, as a multi-part file, and then it is flowing into a service and its method called process XML file. So ACID is entering your application through an entry point, which is called the source. Then it is flowing into sinks. Sinks are essentially areas in your code base where this ACID which is flowing is processed in an insecure way. Here, in this case, it's entering your code base as a file, and then it's processed as an XML file, where you can see that the XML file is being parsed directly without any sanitizations, without enabling any safety measures like disabling DTT, disabling external entities. So in this particular case, this is an XXE, XML external entity, basically vulnerability here. So that is how acid flows, and that is how acid burns your application. So we have to be careful about that. Now, sources and sinks. Back to sources and sinks. Source, again, input, entry points. Anywhere that you are accepting user input is a source. Anywhere you are processing that user input is a sink. And this is not the same for each and every application. The concept is the same, but the methods, the patterns, they are not the same for each and every application or each and every language. For Python, here are some examples. For Java, here are some examples, and C and C++. Likewise. So you will get an extensive list if you look it up, you'll get an extensive list. And most of the cases, most of the SaaS tooling or any tooling that you have in place, they already have a dictionary of these sources and sinks, so you don't have to worry about memorizing anything. So don't worry. So essentially, these are some examples of sources and sinks, and that's essentially what acid is, right? The main thing that you're going to be chasing when you're doing a code review. So now that you know what you're looking for acid basically. You're looking for You're chasing acid, you're chasing the flow of taint, how input data is coming in, how it's processed, and where it's going. So, how do you do that? So, there are multiple approaches towards it. But even before you begin, step zero starts at getting the manual and reading the manual. The code review, the biggest benefit of code review is everything is open to you, right? It's white boxed. So make the most of it. Get as much documentation, as much support information you can about a code base, and ingest it. Make sure that you are reading and gathering as much documentation as possible, because that is what is going to build your context, and that's what's going to help you build your mental model about what should be going on in the application and what should not be going on in the application. Once you have your documentation ready and you have been through it and you have a somewhat idea of what it's supposed to be and what it's not supposed to be, you can move on to some approaches. Now, bear in mind, this is not a set in stone approach, right? These approaches that I'm going to mention, these are not set in stone. And you will realize that some of these approaches are even subsets of each other. So it's not like you'll have to do these exactly to do a code review, not at all. This is deeply subjective. And it really depends on the scope of your code review. Are you reviewing the entire code base? Are you reviewing a component? Are you reviewing just some pull requests? There is a new release coming and you're reviewing the pull requests. Or are you reviewing output from SaaS tooling, DevSecOps tooling that you have, like Sneak, SemGrep, CodeQL, whatever? You have that and you're reviewing the output. So it totally depends on these factors. And most important factor is how much time do you have, right? The better, the more the amount of time you have, the better, obviously, the outcome will be. But you can work with limited times as well. It's not an issue at all, given that you're following the right approaches. So starting off some basic approaches, the very basic approach is source to sink, right? You find all the entry points, you get all the entry points, your you can use your code editor to do that with LSP enabled, you can use the documentation, whatever. Find all the entry points, sorry, find all the entry points, and then you look for how the data is being processed, right? The acid is entering the sink source, and how is it flowing to the sink, right? So pretty much an example would be in a Flask application, you know that like routes are declared like this, right? So you can look into all the user entry points, all the routes that are declared, and you can then verify how the request data is being parsed, where it's being parsed, how it's being processed, etc. That's very basic source to sink, right? Bottom up, you can do the opposite. You can go from sink to source. So instead of going from the entry point, finding the entry points and tracing the data from there, you can go the opposite. You can do pattern matching, grep, rep grep, whatever you prefer, and find sinks, right? Which are again unsafe functions in an application, not necessarily an application, but a language and a tech stack. So you can rip grep, you can pattern match for those vulnerable functions, vulnerable patterns, and then you can traverse backwards. So once you have the pattern here, you're going to traverse backwards. So let's say there's a vulnerable function eval, right? So there's eval, and you're seeing that eval is somewhere used on line 100, 150 or whatever. You're going to look back which function is calling eval and how, and is there any input data which is flowing into eval without being sanitized or validated. So that's how you're going to do the reversal, right? Pattern matching, simple. You can use rip grep. You can use interactive tooling like John, which basically parses the AST and creates a code property graph. It's very interactive. So you can use whatever tooling works for you. But essentially what you're doing is pattern matching, right? You're finding the things and going backwards from it. Third one. The third one is basically using SaaS tooling, running SaaS tool, checking the output, and basically triaging it. So you are essentially leveling up your pattern matching into the next level by looking into semantic greps, semantic pattern matching, and proper SaaS tooling like CodeQL, SemGrep, etc. So you can run SemGrep on your code base, get the list of all the outputs, all the code findings that it has. Not necessarily just SemGrep, by the way, any SaaS tooling you prefer. Get the list of findings that it has and manually verify each and every one of them. The tooling will give you at least a basic taint of the data flow. It's also doing taint analysis, by the way, internally. So it will give you a basic taint of the taint and exactly what is wrong, what it thinks is wrong with your code, right? Maybe it's flowing into a concatenated SQL query. Maybe you're using eval in an unsafe way. So that's what you can use SAST for. You can use it as a GPS if you feel overwhelmed, and and sometimes you don't have an option, right? Sometimes all you are doing is vulnerability triage of SAST output. So in that case, it works like that. You use the SAST as a baseline for navigation, and then you traverse whatever findings it has, and then you make a verdict based on your analysis of the finding. And beyond these pattern matching and SAS tooling, you can browse randomly, basically just wipe browse the code base, or you can do it a bit pseudo randomly with making use of historical data. Now, keep in mind the terms random and pseudo random. We're going to look into these terms deeply when we do the bootcamp. So yes. So when you're doing random browsing, you are basically just taking the entire code base and just getting into it like an adventure, just going through the flows, going to the different functionalities, etc. It's just basically just wipe checking. And pseudo random with historical data. What I mean by that is chances are, if your code base that you're handling is not a new product, like brand new product, chances are there have been vulnerabilities historically that have been found in that code base, right? So what you can do is you can use that historical vulnerability data to zero in on components which have been uh, previously targeted and previously found as vulnerable, right? So you can basically quickly map out an attack surface and quickly come up with threats to the application by looking at historically where it has been weak, right? Where there have been gaps. Now, the final way of doing approach of doing code reviews is essentially feature exploration. This is the most comprehensive and wholesome way to do code reviews. What you do here is you basically take all the documentation from step zero, you take it, you ingest it, use whatever artifacts you have, Swagger, like API endpoint, Swagger UI, full documentation, LLDs, HLDs, you use all these information to jot down, take notes of all the core functionalities, right? Core functionalities in your application. And once you have the core functionalities, you browse these functionalities, you map them to the code, like each functionality to the code, where it's happening, how it's happening, and you explore it one by one, or however you want to. But essentially, you are getting a full picture. This is a big picture way of doing a code review, right? You're getting you're doing a code review of the entire application itself, and you're not really focusing on a single PR or a single SAST output. So this is the most wholesome way, but again, this is the most time-consuming way to do it because again, you're dealing with a large scope code review. So now that you know how to look for things, what are you actually looking for? You're looking for taint. That is true. You're looking for acid flow. But exactly what are you looking for in that data flow? You're looking for things and places and processes in your code base where data is being transformed. Anything with parse, serialization, deserialization, compression, decompression, decode, etc. Anywhere data is being transformed is a potential place where discrepancies can occur, right? Parser differentials, we have seen them over and over again. Trust boundary crossing points. Now, this is an interesting one. So, trust boundary, in a very simplistic way to describe it, essentially is the point where low trust data or low trust region is the gap between the low trust region and the high trust region, right? Where low trust data, for example, network data, for example, user input data, is crossing the line and is coming into an area where things are high trust. So, the input data coming into an endpoint and then being processed, it's crossing a trust boundary. It's coming from a low trust area, which is external network data, and it's flowing into internal application, right? In your application. So that's high trust area. So that's what a trust boundary is, and that's what you look for. Like basically components where again it's the same thing, right? It's the same thing. You're looking at ACID. Then cross-component boundaries. In many cases, we are dealing with microservices or monolithic architectures, whatever we are dealing with. Many cases, there are multiple different components which are processing the data, right? And these components, they are processing the data and they are transferring the data amongst each other for whatever business logic, processing, etc. You want to look at these boundaries where this happens, right? Where the data flows from one component into an entirely different component. Again, another place for data transformation and potentially discrepancies. Complex functionalities. We circle back to step zero, get the documentation, find out what functionalities are there, what features are there, map it, and then we explore it. Authentication, authorization, any sort of crypto like encryption, decryption, logging, etc., data processing, anything which is of high value, which is complex, you're going to look at it. So that's pretty much how you do things, right? That's pretty much all for the approach. And let's put that approach to use. Let's do it live. For doing it live, we're going to be using an intentionally vulnerable application, which is Bank, and we're going to try and find a vulnerability in it by manually reviewing it, exactly in implementing what we just learned, the approach we just learned, right? So let me just share my entire screen.
So this lab that you'll be showing us right now will be pretty much the same as what will be in the final boot camp as well, right?
Not really, no, not at all. This is a just a taste of it. In the final bootcamp, we'll be actually delving into real world software. So this
Okay.
is just demo. This is just demo because we are running a webinar, right? So 30 minutes to
Right.
think like an attacker. We are racing against time. So this is just a demo which is intentionally vulnerable, right? But in the boot camp, the idea is that we're going to be looking at real world software, real world and heavily used software like transformers, pytorch, etc. And we're going to be looking at the software and trying to find vulnerabilities there. And it's going to be
Oh,
fully real, no simulation. It's going to be fully real.
nice. That sounds really exciting. Go ahead.
It will be. So yeah. So again, so we'll apply whatever we learned, right? We'll apply whatever we learned. Basically, the idea was the approach. One of the approaches was finding user input and then process and then analyzing how user input is being processed, right? We find the entry point and then we analyze how the data is coming to the entry point and where it's going from the entry point. So this is a Flask application. So in Flask applications, as you must know that routes are defined like this, right? So what we can do is we can take a look at all the routes. We can take a look at all the routes and check whether if there is any insecure pattern, if there is any vulnerability in one of the places. So that's how we can do it for this particular application. Now, you can make use of the documentation here. Again, documentation is your best friend, so make use of documentation as much as you can, or you can use your code editor. Which an important point, that is your editor is your best friend. Your code editor, your tooling is your best friend, right? Most of the time you're going to be spending in the code editor. You can use SemGrep, you can use John, but most of the time you'll be spending in the code editor. It's pretty much like 4 hours to chop a tree, 3 hours to sharpen the blade, or 4 hours, 2 hours, whatever. That's the same thing. As your entire experience of doing a code review relies on how well set up your environment is, right? So you should have your code editor ready to go, virtual environments ready to go, and LSP set up. Everything should be set up, right? So back to the topic. So yes, so let's look at some routes, right? So we have the root route, which is just dashboard, which will just be the index. Then we have register, we have login, debug, dashboards. We have a couple of interesting routes, like a lot of routes actually. So let's just focus on the most rudimentary route in any application, any web app. Login, right? Login registration, very rudimentary and is there in literally every web app ever. So okay, by the way, for those initiated, I basically already I just did a find all references to get this window that you're seeing. I just did a find all references. I have a key binding set, so it didn't show up, but basically that's what I did. And that's how you can basically find exactly where this route variable has been used, app.route has been used, right? That's how you get an exhaustive list of all the routes that are present in this application. So let's take a look at this code, right? So app.route is our entry point. So let's mark it there, entry point. One of the potential entry points. So here, this is Flask code. And even if you're not familiar with Flask code, just follow along and read it like English. It's Python, right? It should be quite easy to follow. So there is a login endpoint which accepts HTTP methods get and post. And there is a login functionality when you hit that login endpoint. So it's saying that if the request is post request, then you get the request, you get the data from the request body. So request.json. So JSON in a JSON, I believe the front end is sending request to the back end in JSON format, and you are basically accepting that and serializing that into the data variable, right? You're getting the JSON and putting that in the data variable. So can you spot the asset here? The asset here is this. The asset here has started here and data. This is where the acid has started flowing. Attacker controlled input data. For the again, just to recap. So data. So what you're doing? You're doing data. You're storing all the request data in data, and then you're declaring two variables, username and password, from where you're getting the value of username and password keys, and you're storing them in username and password. Now, this might look harmless, I mean, just the username and password, but if you're thinking from a code review perspective, this is user input. This is untrusted user input. There is no validation around here. There is no validation of such around here. So this is untrusted user input. So this is acid, right? So this is acid, and acid is flowing. Acid is flowing in your application. For even your own help when you're taking notes or when you're parsing, you can rename variables as well. Again, very important to have your environment set up. So I have LSP set up. So if I just click F2 and I rename it to acid username, everywhere it's used, it will be changed into acid username. So I won't be having to manually change it. Same for this. Let's change it acid password. And everywhere you see it's changed to acid password. So to find where everything is used, wherever this particular variable is used, we can do again same, find all references, or I'll press alt X, which is the keybind which I have set it. And there it shows me that username has been used here, here, and here. So in four places, actually three places, it has been used once it is initialized. So at the first place where it has been used, we can see it's being logged. Now, it's very simple, looks just a print, but this is dangerous. Why? Because there is a vulnerability called log forging or log injection, not to be confused with log4j, by the way. These two are different. So essentially what it's doing is your application is accepting user input, which is acid username and password, and it's printing it and it's logging it to the console. And if that particular input has, let's say, escape characters, special characters, it might be possible for an attacker to inject fake logs in your application, or even to an extent execute arbitrary commands as well, in many cases, not necessarily in this case, but in many cases. So this is a vulnerability right here. Unsanitized input is flowing into log. So we will mark it as such, and we'll take notes. You will obviously take notes when you're doing a code review. You should definitely take notes externally. So we'll mark it as uh, acid log without any sanitization, possible log injection, log fortune, right? These are just notes for us. So that is one thing. So we have already found something. We're not even like, but we are like 10 lines deep, and we have already found something, right? That's how you follow acid, and that's how you basically make sense of how it's flowing and how it's affecting. Okay, on the next line, we see that there is a query variable which is commonly used to declare SQL queries for database. So we see that there is a SQL query here. Select all from users where username is acid username and password is, I'll just close this, password is acid password. So essentially what it's doing is it's concatenating user input, untrusted user input, directly to a SQL query. And if we check where this is used, and it's executed. Yeah, by checking the references where this query variable is used, we can find that it's being executed over here, just one line below. So what you are seeing here right now is a classic example of SQL injection. SQL injection via acid or untrusted input concatenation into SQL query. So right now, right here, you are seeing SQL injection. That's as simple as that. Now, obviously, this is a demo. So it's more simple than it's supposed to be. And in many cases, you will be chasing through lines like a super long call chain, multiple files, multiple functions. But this is essentially the idea of doing code review. You find the entry point. One of the ways to do it. You find the entry point. You locate where input data is being stored, where input data is coming into your application, and then you find everywhere that it is being used. We found that input data is being used here in three places. It's used in the query, and it's used to print logs. It's used to save logs, and it's used in SQL queries, in executing SQL queries. And that's how we came to know that when we came to the verdict that because it's unsanitized, because there is no validation before, there's no masking, there's no validation applied before this data is flowing into the SQL query and flowing into the logs, added to the logs. We can be 100% certain that this is vulnerable to SQL injection. If you want to validate, you can do it yourself. You can execute the file, the application. You can run the application, and you can validate for yourself. But I'm not going to be doing that here, because generally in code reviews you will not be doing that. Actually, in code reviews you will most probably not be running the application, but if you will, it shouldn't be that hard. It really shouldn't be that hard, and we'll be going into it in the boot camp anyways. But you probably won't be. So in that case, what you do is you basically give them, when you're giving the report, when you're giving your verdict, you basically give them the full taint. That user input is entering through the route slash login. It is being stored in username and password variables, which are then printed into logs and used directly in SQL queries, concatenated SQL queries, which is then executed. So there is a SQL injection in this full call chain. That's how you describe your vulnerability when you give the verdict. Now, this is one way to look at the code base. Like I said, we are looking at entry points and then we are browsing from there, going from there. The other ways can be to run SAS tools. So here, for example, I've run a SAS tool, which is semgrep, and it has some interesting findings. It has 95 findings. So what you could do is basically look at the findings, look at this curve, the file name, and the code line it's giving you, and you can validate. You can go backwards, right? It's kind of again bottom up because it's giving you the sync, and you can go backwards. Although in CodeQL, semgrep, and John as well, you can do taint analysis, like, and you can do full intra-file taint analysis as well. We'll go into these deeper in the bootcamp. So essentially, you can use semgrep, and alternatively, you can run for just basic query matching, sorry, pattern matching. You can run ribgrep, and yeah, ribgrep is basically finding all the things that I gave it, and it's giving me which line it is. And again, it's up to me to go back to check it, to go back and validate. Okay, in line 144.25, there is, in this particular file, there is this query parameter being used. Whether this is even used in a proper way or wrong way, it's up to me. So it's very raw pattern matching. But with semgrep, it gives you at least, like, there's a vulnerability here, and this is what I found in this line, right? That's pretty much the difference. And the third way is full manual, which we just did. So I'll be changing my stream back to the slides. Right. So review it live. We just did. We reviewed it live. We learned about the approaches. We learned about what we are actually doing in a code review, what we are chasing. We learned how to chase it. We learned where to look, and we applied all that right now in a very simple demo, in a very simple but realistic demo. But what next? So already know what to do, right? But what next? Just with any other skill, practice. The more code you read, the more anti patterns you read, you get come across, the better your sense gets, right? Your exploit sense gets. The better you'll be able to intuitively tell whether, okay, this could be a problem. This seems off. Like, that intuition, it will build as much as you practice. AppSecEngineer has great labs for practicing it. Do check it out. CV analysis and end expert. So another interesting thing that you can do, and in that process, maybe land some cool CVs for yourself and your resume, is CV analysis and end expert by extension. So CV analysis is basically CVs. I'm sure that most of you are familiar, but for those uninitiated, CVE ID is a unique number associated with a vulnerability that has been discovered in a software. So you basically take that CV number, basically search it up, and you look for where the vulnerability happened and what the patch was. You will find that it's mostly in open source. If it's an open source software, you'll be able to find the exact patch, exact commit where it was fixed, exact commit where it was introduced. So what you can do with all this information, you can study it yourself to understand, to build an intuition of how exactly this was introduced and how you could have got it, right? And by extension, what you can do is end exploitative. So end exploitative basically means there is a CV which is out, and it has been out for a couple of days. So the vendors know, the maintainers know, everyone knows about the CV. So what you can do is you can take the CV, study it, understand the root cause of the vulnerability, and write an exploit POC, A POC is basically a proof of concept, which has code which will be exploiting a vulnerability in a software. In this case, it happens to be a CV, which you are doing an end exploit for. So this not only helps with your analysis, intuition building, but also you're improving your exploit development skills, which will come really handy whether you're doing pen test, code reviews, whatever. Track exploit primitives and gadgets in your own code base. So again, you want to make the process as in tune to your code base as possible, right? As fine tuned to your code base as possible. So study your code base, whatever products that you're in charge of, it's your responsibility. Study them, find the historical data of exploits, vulnerabilities that have been there, and try to come up with patterns and basically primitives, right? Insecure code, which is not probably yet a problem, but it will be. So what we call security debt, right? Try to notice these patterns, try to come up with these and keep track of them so that in future, let's say there's a code change which introduces a vulnerability, you will be able to chain these primitives, these gadgets together for maximum impact. And by extension, extract all these patterns and feed them into tooling. Whatever tooling you are using in DevSecOps, feed these patterns into your tooling, build custom rule sets, and basically fine tune it so that your reviews can also be automated to an extent and your overall DevSecOps pipeline is improved and emits less false positives and more true positives. So that's all, folks. That's all for today's webinar. I hope you learned the basics, essential basics of how to do code reviews, why you should do it, and what you're going to get out of it. So that's it, Anish, from my side.
Thanks, Debarshi. That was really interesting, and I think the fact that you mentioned it's like code review is like more about learning, having an instinct for figuring out where
Right,
the issues are with the code. That's a pretty interesting take on that. Like I think that's a bit different from other disciplines in application security. So I think that's something that our learners are really going to look forward to in the boot camp that you'll be hosting.
right,
Just to give you a little bit more details, so I this when you sign up for this boot camp, you are basically going to be attending the live class, and you get access to the recorded content for 1 full year after the purchase. But also you'll be getting whole year of access to the AppSec Engineer Pro Plus subscription, which means all the courses, all the labs, and all the challenges on our platform. And not only that, you'll also be able to take a certification exam in the relevant AppSec Engineer certification, which you'll need to take within 1 year of attending the bootcamp. And with that, you'll officially be a certified application security professional with hands-on skills in real-world problem solving and security knowledge. So, by the way, we are giving a 10% discount code for all the people attending this webinar and have stayed to the end. So, like I said, I had a surprise for you, and this is it. So, use the code DABE10 to get 10% off on the Certified Secure Code Reviewer Bootcamp. So, please go ahead and check that out. We'll be including links to all of this down below where you can get more details. And let me just say that this is one of the most incredible learning opportunities available anywhere in the industry. And I can't wait for all of you to experience it live when Debarshi takes this class for you on our 4-day bootcamp. So look forward to that. And thank you for attending this webinar. Thank you, Debarshi. See ya.
thank you so much. See ya.